Alright, so I had to downclock my PC real quick. This motherboard is dying, it can't handle that voltage anymore, I think. So I went from 4.5 to 4.4 gigahertz, where it was originally stable at 4.7. Not that it matters, it can still run VR thankfully. And I'll be upgrading in a couple months. And never buying a VRM motherboard again that's cheap. Never buy a cheap motherboard. That's the lesson to be learned by this. Ever. VRMs are just too important. Okay, that's loading. I'm gonna try to run Firefox. It probably won't work. That thing is pretty much screwed, and hopefully my Chrome is not screwed after that. That was also very, very bad crash. Too late for this stuff. VR is still starting up. I don't even have VR connected right now, and it's still starting up. There's Google Chrome. Yeah, I can restore these at least. Firefox is dead.
Be aware that that ever happened, because at the end of the frame, when it's considered for replication, it will say, well, I started at 100, my current value is 100, no change has occurred, I don't need to tell the client machines about that. So it's important to realize that if you're
Okay, I'm still considering this part too because the other part was literally like 5 minutes and a crash. There should be 4 parts because I tried attempting it once and it instantly crashed after the first crash. So yeah, well there's 3 on here that I've seen so far that I have to look into. And okay, back to what I was doing while this thing compiles. It's probably going to crash while it compiles. I am hoping it doesn't, because the compiling is what's doing it. Even if I turn off OBS, compiling can crash the CPU because of just how much of the CPU is being used. Like if just one part of the CPU gets a bad voltage from these VRMs, it's going to fuck it with these sensitive calculations. So we'll see if downclocking it helped. Hopefully it did and it's more stable now.
changing the same value multiple times in one frame, it won't be captured. Only the very last change that you make in the same frame will be captured. And then, just to drive it home one more time, you really don't want to be modifying replicated variables on the client. You want the server to be the one that makes the change, and then rely on the variable replication system that's occurring to make sure that the client gets the change. So in here, we would never directly set the health value on the client machine, only if it's authority guarded, because we don't want.
I'm looking for replications right now.
Okay. So I mean that's about it for this simple example. One other
network
thing
features.
Maybe calling out too while we're here. Probably should have brought it up a little bit in the
open this up.
Is some functions in
this looks the same.
Give you hints about where and when they can be used. So as an example, if we look for
awesome
apply damage, this guy has up in his corner a little teeny
server. So as soon as this thing finishes rendering, I'm going to try using this thing and see what's inside.
Work if you call it on the server. So you can try to call it on the client, and this is going to do nothing. So it's kind of
change this back to tiles because I like tiles a lot.
But it's
opening this up so I can see the content folder.
So if you see it, you know, hey, this code only can possibly execute on the server. This node is not going to do anything at all.
Finding that.
If I happen to call it on a client or.
Let's say you have a small computer screen, right?
Actually another one.
I mean, you don't really want all this shit open because you're on a Microsoft Surface and it's taking up too much space. So what you can do is you can double click these little corners here and you can move them to different spaces. So what I like to do, for example, is I'll shove toolbar right here. put it with content browser because you don't really need to see this all the time. Now get this stuff over here. Modes I like to put down here. World outliner I like to put next to details right here. This is how I have it set up on my laptop. Since I'm on a 1080p desktop display, I really don't need to do this because I have more than enough detail. But if you like having more space for like this thing, for example, you could use this route and your productivity won't be hurt that much at all. Just an option to think about. And if you want to make the hidden tabs again, you just do that. I'll keep that there and I'll move the world outliner back. I can just hide tab. There you go. Almost done compiling shaders. Load up this web page. This is a pretty decent series. I would recommend you guys look over it when you can after the stream or before next meeting, so that you just have this wrapped up around your mind, at least buffered, so that you have something to remember vaguely. Because the meeting, we want to do stuff. We don't want to go over things. Think of it as a class. The reason the professor keeps asking you to read shit before you go into class is he doesn't want to try to explain shit that you already know. He wants to try to apply what you tried learning, or try to grease out the shit that you don't remember that you should have. That's almost done. Let me make sure VR is not ringing. I mean, the Firefox not ringing in the background. In case it is. Probably, yeah, it's cache is messed up from that crash. I gotta clear it. Where's Firefox? Good enough. This is almost done. Fonts that guy was using, same exact ones. To go to blueprints. Guessing that's one of those or something else over here. You don't have them sorted by the map, I'm assuming, so everything's all at once. They don't have much though, so there's a benefit. Unless they have it. No. Bunch of stuff in here. Network features. They do! Awesome. So here's every example we would want. Did I save that screenshot? No. Alright, I'll screenshot it again. Yeah, I need to delete that. Posting it in chat. Highly recommend looking through that later. Probably got so much stuff that pretty much everything I would consider to be in here almost that we would possibly want to know what that looks like. All right, back to this.
Let's look real quick. Another one that you may want to be aware of is this little icon right here with a little monitor and a lightning bolt. This effectively means anything called after this point, you are promising is only going to happen, like, is basically for cosmetic or visual effects. And so you're not going to do anything that's like super important to gameplay or that should only happen on the server. So this one in particular is with the HUD, right? So this is drawing HUD elements, and whatever you do, you happen to do. The server doesn't.
And
really
the computer state, thank goodness.
If we were running a dedicated server environment, or if you recall back from the previous examples where we had a listen server and a dedicated server, anything preceding, or excuse me, following this node on a dedicated server is straight up not executed as an optimization.
I think this will play. No, it's frozen. I hope it didn't crash. Okay, so it's showing server. I want this to be on a separate client. Okay. I'm going to do is advanced settings. Turn on my numlock because it was off from that crash. I'm going to do Stanford definition windows. With 2 players. And I won't run dedicated server so we can see what that's like. Awesome. So now I should see, yep, there's the player. And it works right off the bat in this client map. This would be a pretty decent place to look at the code for. Maybe it has better code to look at for our project to do from scratch. If we ever have to do a map from scratch, we may be doing that. In case Matt gets his assets together for an even better cowboy map than what we currently have. Let me try the other server, the client. You can see the client doesn't have the no replication. Remote client, it knows. 0 help, this shows 70, yep. Cool. Function call happens. Let me see if I could see that on the other one. This one can see after replication. See the health difference, I'm pretty sure. Yeah, 80, 70. Okay. Oh. Hello. Yep. Okay. Great little map to test stuff on. So I'm going to start looking at what code they have. Before I dive into this, I want to have 2 references to content. So right now I have a reference to demo room. Oh, not demo room. Example content, network features, and I want to have another reference to that. So you can go into the not viewport. Where is it? Content browser. You can open multiple content browsers, and if you have multiple screens, you can put it to the side like I can, or you can just put them here. So I'm gonna have mine floating around. It'll stay on top, so it's no big deal. This corner area is not really being used. Or hold on, I can do this. Yeah, I'll do this. Okay. This one will reference anything else I want to see at the same time. For any reason. This is a lot of shit in here. There's blueprint. I'm gonna go back to that area. your effects, materials, which are being used by these guys over here. Meshes, again, used by these things. The blueprint grabs the mesh and all that stuff. I'll show you where the link them together if you haven't seen that yet, which you should have by now if you were looking at least looking at Unreal already. Nothing in example content so far that I care about. Blueprint communicator, what the heck is it? Might be using a different map. Looks like it. Looks like a button. Yeah. Make it a little bit smaller so I can read this. Pretty much has an example of all the starter stuff. Loading screens. I'm looking for... I already saw the network stuff. I'm wondering if UMG... Hold on. Is this all the UMGs? You have an example of a render target. Render target. So a render target is just a place to render something. In this case, it's a 2D thing. So a render target will render a 2D plane of any texture you want anywhere in a 3D space for Unreal. Essentially, they call it that in other engines as well. That's a very basic thing right here. That's probably like really low level Unreal. Because all this stuff, the UMG stuff, these things are all built upon render targets. Well, the 2D images and stuff like that. Or the textures on top of models all use render targets. Surface of the model's plane is a render target. That way they can actually put the texture on the mesh. Unless Unreal does something really weird. Or they do something more advanced with mesh objects nowadays. And they used to. Anything that says UMG is related to just the UI, this interface. It's like basically Adobe Flash, or this other thing that they use. I forgot what it's called, but it's basically Adobe Flash. It almost has as much features as Adobe Flash. It's insane how much to do with this stuff. An input that it would show here. I'm guessing this is an input bind. I'm not too sure. I forgot what's going on. I don't know what the heck's going on here, to be honest. Look at the graph. Unclicked. Yeah, this looks like it's trying to get a bind, but I'm not too sure completely. The way to describe what it's doing is this. It's pretty abstract. They didn't really specify if it was specifically an input. Only the title does. Tutorials here? Okay, that's just a reference. Okay, that's just the regular panorama they use for looking at models. So this thing right here, if you look at it, it looks like this. You'll see this a lot. Preview meshes, like just in general, unless you have your own, which 9 times out of 10 we're just going to be using that thing because we don't bother with that. So for example, if we go to the Hero TPP file, which this thing is using a lot, you'll see in the background right here. And using its default lighting, you view the character model using that rendering, and its reflections will show that skybox. And you'll see it in all your mesh samples. So when you look at a mesh, it'll have automatically, when you import like an FBX file, it'll automatically ask you if you want to attach a skeleton to it, animations related to it, the blueprint it's related to, physics. They all get like interwoven with each other, even though they're not directly shown to be related to each other in Unreal Engine. They'll be put in, usually you would want to put them in the same folder, but they'll be separate files. But when you open up the interface for it, they'll always have a reference shortcut to the other file that's related to the blueprint, at least to an extent. And you'll see that here, I'll highlight. Now I'm in blueprint for the animation. This is the animation blueprint. This is the animations themselves, which you can look through each one. Got a bunch of basic animations Mesh can use, which are, it's using the skeleton reference to know which bones to move, and the keyframes are stored in the animation blueprint, the animation file. And then Unreal Engine can interpolate those animations. So instead of it being these 27 frames only, it could add in between frames. So this right here, you can do it either step, which means it's going to look more jaggy, which they use in games like the last game that came out, which was Dragon Ball FighterZ, I think. They use that a lot to make it look more anime-ish, where they limit the frame rate. Because low budget animation, which is the most popular kind, uses limited frames because they don't have time to animate all that bullshit. But for video games, most of the time they do a linear interpolation to make everything look smoother because it looks more realistic. Just the basic information on the mesh. You can add an animation mode here if you want. Add an animation to it. See it while in the mesh mode. So it allows you to access features even in the different windows that are not specifically meant to show those features, just so you could. Change the material here. Something completely random for no reason. It allows you to interchange materials on the fly. Probably the one they're using in the multiplayer thing that we were seeing. Change it to blue. They already have a bunch of materials set up that just work right out the model and they look good. Physics. Okay, so I don't know how to use these yet properly, but there's like different modes that Unreal. This is now getting outside of the multiplayer stuff, but I'll just go over this real quick before I start refactoring the other project because I pretty much saw what I wanted to from this. Now I'm just going over some stuff. Let me go back to the mesh. Was I here? Yeah, physics. Okay, here. So meshes can come from like Blender, Maya, Autodesk, whatever, 3D Max. They can come with their physics collision boxes already preset and done. Unreal can import them and determine how it wants to interpret those hitboxes as. And in this case, this mod already has some hitboxes set up that are really nice that are being used for physics. I'm pretty sure you can use them for in-game checks. I just don't know how to properly use them and how to set up the blueprint, the actual character blueprint, which is not here. I don't know where the hell that is. I need to look for it. It's most likely in either network features as its own blueprint. No. Here. Most likely something to do with when I go to the mesh, or this player character, how it does collisions, has an option for that. How this thing uses collision presets to detect an impact, but right now by default Unity always uses the more basic collision detection, which is just this capsule thing around it. That's its basic interaction. But if you want to do anything physics related, such as walking on steps in the environment, it will usually use these colliders here. Determine more precisely where the steps are and where the feet positioning collides, the foot exactly collides, because you can't really do that with this big ass hitbox. They just have basic controls in here for movement and mouse input. I don't think it does anything beyond that. Instruction script has something. Nope. That's all it does. And it's got these funny little models on it. They're great. There they are. And they're just attached to sockets. I'm pretty sure this is to show how sockets work. Yeah. Left weapon. Change them on the fly. Yep. Put it back. Model has sockets. Let me show you what those look like. I think they're on the skeleton. Left weapon. For some reason, yeah, there's a socket for the left weapon. You can do a preview on there, and you can put stuff on it. So sockets allow you basically to attach other objects that are meshes or blueprints, whatever, to it. If I wanted to, I could attach another player TPP to that socket. You can use it as a weapon if you wanted to. For some stupid reason if you wanted to. But that's for later. Maybe you can throw heroes at people during our game. That's basically it for the basic rundown of a bunch of stuff. I'm gonna go look through the blueprints now if I can. Really quick to see what's going on inside, even though I saw most of it from the tutorials. 1042. I'll stop at 11 and go to refactoring. When the button's pressed, this is our events. You can literally create events very easily. Where it's referenced, if at all. So in order to create an event, you'll just go event. These are the default events. You can add a custom event, which is what this is. I believe this is what that is, and you can name it whatever you want. And you can define it, and then something else like this can call the event. And they'll do whatever thing this event's supposed to have done, or this event may call a bunch of functions or tell a bunch of other functions that this happened, or objects, whatever. It can do a bunch of things. It's just how regular event systems work if you got to that point in programming class, which I officially didn't, but I just learned some of it myself. I do not know if Unreal Engine has anything past a basic event system that's just on a queue, or first come first serve, like how it does it. I'm not too sure. I forgot. This is just checking if a hitbox happens. So if you overlap the hitbox with the button, it tells that the button's been pressed or the button's been released. And the target is the event itself. So this is for button pressed. And this is for the event of a button being released. So these are, notice that it doesn't use the same icon as a function icon. They are event icons. They're separate. They are separate. And this is just doing a bunch of stuff, show that the button's been pressed and what actions the button would do because of it being pressed. That's cool. This is blueprints related to the game mode. We're on a network. This deals with spawning the actors of class players start that are in there, and it does it by the spawn order. So whoever is first goes to the first spawn, which is usually the server, and then the rest of the clients that add in, the spawn order gets updated. So the next one that comes in will be the next spawn, and it does it by this, what is this, an integer? Yeah. Uses an integer to determine which index is next to the spawn actor. Okay. So this is the same, this was the things you saw in the tutorial, which you can look at later. This has no replication setup, since you won't see it in the blueprint. It's going to be here. Where is it? It should be here. Class defaults. There it is. You have to click on class defaults to see this. And you'll see if it can replicate movement or just replicate period. And the other one, it should be exactly the same. We're in, I want to see the full blueprint because that's what I usually see. And you should see that. Net load on client and replicate. The more advanced version, where it gives it denotes authority to different characteristics or functionality of this blueprint, either the server or the client. Variable replication. So this is just more advanced stuff. This is the last part that we were on the tutorial, I believe. the networking HUD, which shows those HP values. No, wait. What about distance field? I'll look at that later. Let me go back to that video. How much time do I got left? 47. One has to notify. Free. Okay. I gotta look into this later. This is related to function replication. I'm gonna look through the video real quick.
Because as it even says in the tooltip here, cosmetic. This event is for only cosmetic non-gameplay actions. So this, if you see an event with this mark, it's basically a contract that you're signing that everything you do afterwards won't affect gameplay and can be completely ignored by a dedicated server. Okay, now that we've covered that little side tangent, if we hop back into our example, we want to make one more point about variable replication, and that is, if you happen to notice when I looked in the last dropdown.
It's talking about the street light.
Let's go ahead and look at our variable. We had, in the last example, replicated, but there's another example down here called rep notify, and this one is also really important to know about and very useful. So rep notify basically means do everything that the replicated keyword that we just went over does. But in addition, when that variable does change, if somebody modifies it, give me a chance to respond to that, right? Allow me to call a function in response and do something with it. So before we get too much in depth, let's go ahead and look at the example and see what's going on. So if we look at the server, we have a street light here that's going between red and yellow and green. It's following a cycle. And the client is synced up, right? He sees the same things that the server sees. So how did we actually accomplish this? What we did is we used a variable marked rep notify, and let's go ahead and take a look at how that's working. So first, we have our script here that's controlling the primary switching of the color, or the street light from red to green to yellow, and so on and so forth. And here's our friend, the authority guard again, because we want only the server to control something important, like whether that street light is saying it's safe to go or not. If this was a racing game, obviously you don't want the client to say like, oh, green light means go, here we go. And so we have a very simple setup in which there's a delay on how long the green light is. Then we are setting a variable that is swapping it over to yellow. It's telling it that it should be in the yellow state, delay, swap it to red, delay, swap it to green, and then go ahead and repeat the whole process again with a custom event back here. So the thing to notice is this right here says set with notify. This is basically on the server, we have set this variable, streetlight scalar, that is marked rep notify, and it's letting us know. Also, you'll notice that there's some iconography here of two little balls. That basically means a replicated variable. So at a glance, you can tell streetlight scalar is a replicated variable. And then because it says set with notify, we know it is rep notify. So how does rep notify work? Basically what it means, when somebody sets this variable at all, like we're doing right here, set with notify, when this happens, it will automatically call a function that was automatically generated. So when we switched this from none to rep notify, it auto-generated a function up here called onRep underscore and then the name of the variable.
That's
so
it.
We can implement. And so what will happen is when this value is changed on the server, it will immediately call this function on the server. And if we open it up and take a look at what it's doing, it is just setting a material parameter value to actually change the colors on the mesh. And see, here's the replicated value that we set. So when this thing changes and says that it should be green, we're sending that value into a material instance and saying, okay, go ahead and switch to green, go ahead and switch to blue. No, blue is not a part of streetlight. Go ahead and switch to yellow. So then if we go back and look, how does this work on the client? What happens is when you set this and it calls the function immediately on the server, it will also call the very same function on the client when the client is notified of the update. So when the update comes through and the client says, hey, my value changed and I know it maybe it changed to yellow, this function will also get called again on the client, and then the client will execute this code as well. So this is a really handy and powerful way to do things where a gameplay thing changes and it should have associated visual effect changes with it also that the clients need to know about. You can make it rep notify if you want to be notified at the second it changes and then react accordingly. And in this example, we're just driving a material, like I said, on what the street light looks like. One minor caveat, if you happen to be a programmer or you are dealing with programmers who are doing replication in C++ and not through Blueprints, the behavior of the notify is slightly different in Blueprints in that the server, when this is set, automatically calls this function. If you are coding things in C++, it is important to know the rep notify function is not automatically called on the server. If you want it, you have to manually call it. In Blueprints, it is done as a convenience, so you don't even have to worry about it. You just set this, and you know that this function will be called on both the server and all of the remote clients. So there we go. It's a pretty good wrap up on variable replication in most of its forms. And so we're gonna stop part 2 here for now. In the next part.
Okay, so that's part 2. I want to see what they do for the function replication before I move on to refactoring. About 10 minutes. And I'll do more streams like this. I'm just really short on time because of those crashes, and plus I don't have a lot of time this week. I was pretty much out of it for the beginning. I had planned to do something Wednesday, but I was not feeling good. I think I got a little bit of some kind of cold from Mango Hacks.
Of our Blueprint networking tutorial. And our last part, we covered
completely
variable
better though now.
replication, both plain old replication and the rep notify version. And now we're going to go ahead and move on to function call replication. Before we get too much into that, I want to talk about, in general, the strategy between when you would choose between variable replication or function call replication. So the general rule of thumb, and it can change depending on the scenario, but the basic rule of thumb you want to follow is if something should occur networked and it's kind of a one-off event and it only needs to happen right away and only once, then function call replication is probably what you want. So like if something explodes, then a function that is replicated that handles the explosion is probably what you're looking for. On the other hand, if what you are changing is something that is going to change and should persist and should be available to clients for a while, so in our last tutorial, our example was a street light in which it was switching between states of red, yellow, and green, then you probably want variable replication. So it's just a handy rule of thumb when you're trying to figure out what is most appropriate. So with that said, let's go ahead and jump into how function replication exists. Before we get too much into it, let's look at this particular example we're going to look at button, and we'll go into the individual parts. So the interesting thing first to look at is this component overlap, which is handling the collision when the player happens to walk over the button, will be called on client and server. They will both get pressed on the button. But we've specifically called switch has authority to make sure only the server gets to decide if you really pressed on the button or not, in case they happen to be slightly gameplay one who decided he. And then if we go look at its detailed properties over here, you'll notice it also has a replicated dropdown, and it has numerous choices. So most custom events will be defaulting to not replicated, which, as you might imagine, means it isn't called anywhere but on the local machine who called it. And then we have some other options. For this particular one right now, we're going to talk about multicast. That's what this one is. So a multicast function means basically when this function is called on the server, you want to make sure you only call it on the server. That's what we're doing right here. And it even says if server. What it will do is execute that event on the server. So we go here, we call it. It is going to execute all of the script that happens after this on the server, which in our case is like pushing the button down, changing a material on the button, spawning a particle effect, making that thing spin, changing some rotation, basically some visual stuff, right? So all of this stuff is going to happen on the server. Then it is going to tell all of the client machines that they also need to call this event. So then each individual client will get this event as well, and then they will run this code as well. So if we go back and look at our example, right? So here's the client. The server touches the button, and he makes sure all of this runs, but he also told the client that he needs to make sure that it runs as well. And so they both went through that exact same code path of the multicast function. We're going to go ahead and look one more time now that we've watched the demo again, right? So the server touches it, makes sure that it's the server's representation of that character who touched it, calls this, which will then execute all of this script, then tells all the clients, hey, you also really need to execute all of this script, which they will do. Now, you may have noticed there were multiple other options here, right? So before we get into the other options in the dropdown, you'll notice there's a checkbox here that says reliable, and we do not have it checked. So if you recall from our variable replication lesson, we said that variable replication was known as reliable, which meant if we changed the value, it would eventually get through to the clients. They were guaranteed to receive it in time. With functions, you actually get a choice on whether that's true or not. And your first blush might be like, well, wait, why don't I just make everything reliable? I always want everyone to know all of these things have happened. But the reality of the situation is, a lot of times where you would want to use one of these functions, it's for things that are purely cosmetic, and you just want to make sure that the visuals happen for everyone, right? So in this case, like somebody pressed the button or whatever. But it wouldn't be the end of the world if somebody happened to not see that button being pressed, because it's not super gameplay relevant, right? And so this is a bit of an optimization. When things are purely cosmetic, you don't say that they're always reliable. We let them be unreliable. And for the vast majority of the time, it's still going to be fine.
Muzzle flashes,
right away. Like you saw, we just did multiple playthroughs.
Stuff like that.
But
bomb,
network bandwidth is
bomb
really
explosions,
full and,
where the players, like say it's Battlefield, where it's
because it's not as important. So this is basically a message, a way for you to say that, hey, you know,
and you don't really care if that player from 30 miles away didn't see this.
You're loaded up with lots of replication.
If they really made it that unoptimized, where they wouldn't have like a distance that would check first to see if the player was even close enough to see this effect happen,
you would make these
that would help.
The case where you would want it to be reliable is where, when this goes off, it's going to affect something very important for gameplay, and it can't be missed, or it's going to be really bad. The other thing to note is how these get handled can change depending on whether it's reliable or not. So when you make something reliable, it will attempt to dispatch immediately, whereas in variable replication, the variables will be reliable, and they will make sure that they get there. But it may take a little bit if there's a lot of traffic. When you make a function call reliable, it will attempt to dispatch it immediately. And so
okay, so that's important. So if you try to organize it as a function, you can make like a really high priority event happen. Like if you just transferred the variable replication to just happen inside a function, you can make it a high priority variable.
Gameplay full of these function calls happening all the time, or you can kill your bandwidth. In fact, with multicast, there's actually an engine feature that is guarding you from hurting yourself too badly. And if you attempt to call one of these, I think it's more than 2 times on
Thanks,
the same network in
Unreal.
the same frame, it will start rejecting further calls to it until the next frame, so that you can't completely flood your network if you make an accident and you, like, for whatever reason, try to call this 100 times in one frame, which would be really bad.
100 times in one
So
frame, holy
the
shit.
basics of how multicast works. The other options on here are slightly more
I
complicated.
would not be
and
surprised if that happened,
into
though.
an example later on in a further tutorial piece. But the basic gist of them is, in this case, we were just using an actor that's out in the world, and so it's not really owned by any particular player. And so those options are not valid options here. World, and so it's not really owned.
Wait, what's he talking about here?
From a client to run a function on the server, or a request from the server to run a function on a particular client that owns an actor. In this case, we're just using an actor that's out in the world, and so it's not really owned by any particular player.
And run it
so
on
those
server.
options are not valid options here. But if you had an option, if you had an actor that somewhere was owned by a player controller, so for instance, if you've done any of the tutorials where you have a little guy running around, a pawn that you control, the pawn is owned by a player controller, and so the pawn or the player controller are both valid options for these other ones. So you could make a function on your pawn where you request that the character, or excuse me, the machine that owns the function request. So you've slightly more complicated, but we're gonna hop into that in the next part.
Okay, so I'll look into that another time. You guys can look at it when you have the chance. The last 2 videos. He adds it to the third person, which may help VR the shootout template. Oh no, not really, because this is already set up in shootout. Well, we can use it as a reference in case shootout doesn't have these stuff we need to make the VR character work properly. Now it's just the second part of doing that, and then network relevancy, which I'll check probably tomorrow while at work. You guys can do there. I'm gonna go over refactoring now because we can at least see how that works, and you guys can get more buffered on how blueprints are like if you're watching this. The rest of the group, they can watch the stream later. It's no big deal. I'm not gonna save what I did here. I'm going to delete one of these, which is this one. That one's not needed. This one works just fine. I'm going to go back to, I think it's multiplayer shootout. Yeah. The C drive version. I'm going to plug in VR again. Oh, shoot, I shouldn't start it up yet until I plug it back in. Oh well. I might have to restart the project and VR when I go test. Okay, so that's plugged in now. I don't have to worry about it later. We're restarting. Whoops. That will be ready eventually. Anything else I gotta look at while I'm waiting? Firefox is so dead, I'm gonna have to reinstall it. Okay, let's see. What am I gonna start refactoring first? Probably not this. This looks fine. Or maybe not. Yeah, I'll start with the VR character. The main thing anyway. So I already did a little bit of that, which is just this show interaction beam. Oh, now I'll start organizing it, which is not a big deal. It's mostly just moving stuff around. I also gotta fix this eventually. I don't think I can do that tonight though. I got 30 minutes, so we'll see how fast I go. So this is that when you say press R, it's really also the press the grip button on the controller, and that resets the orientation. So if I'm a little bit usually I'm above the character a little bit, and I just have to reset my height. That's all that does. So over here, go into here and start fixing this up. I think I'm gonna just get rid of this because I no longer need that. It shows it up here if anything. Next, I'm gonna move some stuff around so I have more space for my event graph. Okay, get out of the way. Don't need to deal with you right now. Things still okay, even though I just moved a tiny bit of stuff. It shouldn't have broken, but just in case. I'm just spreading these out so I can see the path node for the nodes more. A lot of stuff going on here. Where the hell is it? All the way over here? Jeez. This isn't really a limitation of blueprints, but you gotta be careful with it. Unlike regular code, logic can get really messy real fast if you don't start organizing it properly. And then anybody who sees this shit that didn't write it is gonna be like, what the hell? With regular code, you kind of just see it happening so fast that you won't even bother doing it because it would just be too frustrating to deal with. You would just be straight up rating the function. You wouldn't even wait. Okay, so they're just trying to get stuff, widget interaction here. And they're passing a bunch of things over to it from it. So it just wants to make sure all these things are true. So get owner for this. Trying to see how I'm gonna press this side over here. I'm probably gonna group these first. Yeah. So these look groupable nicely. I'm gonna collapse these nodes. And this turned it into like not a full-on macro, but it pretty much behaves like what a macro would be, which is just a macro is literally compressed event graph. That is all a macro is. It's not a function because a function can't do delay timings. Macros have the same functionality as an event graph. They're just compressed. And collapse nodes, collapse graphs are just macros, but instead of going through the process of making a definite macro with a category and all that other shit, it's just you're only going to use it one time, so you only barred making it once. And so it's just going to be a collapse graph at that point. Which is probably what's going to happen to this thing over here, because all this is a specific set of references to this widget interaction thing. So right here, to make this easier to read, I'm going to rename these return values to what their appropriate is active and is over. That's a good word, I guess, for now. This is the direct reference to it, which thankfully already put what it was returning. It's just a direct reference to that. Wait, what is referencing? Traction distance. I'll keep that separate. Yeah, I'll keep that separate for sure. And while this is like a really small collapse, it's not really that big a deal for the grand scheme of things. It adds up. You'll start seeing that soon as I start finishing up this compression. I mean, this refactor really. I'm also going to reorder this. Or wait, hold on. Let me see how this is organized. Yeah, I'm reordering the top one like this. And I don't give a shit how it looks like inside, because all I really care about is that it looks good on the outside. I don't care how it looks in the class graph. It doesn't look as good as it was before. But I can make it work, thankfully, because of how this is set up. Since this is an AND, it doesn't matter the order, so I'm going to switch these around so it looks nicer when I start putting them all together like this. And then I'm going to do a straighten. The output. There we go, so it just looks clean. I do get it to where I want it to be. There we go. One down. Does this have an output? It is, I don't see it anymore. Oh, no, this isn't. Never mind. What am I calling this? Moving this down. Moving this over here. Okay, this is for true. These are both referencing the same thing. Remember when I said the reroute node can be used nicely for splits? There you go. The motion controller looks like it's just trying to get a bunch of information in order to produce the proper raycast. Not completely sure. Where does this go to? Yeah, looks like it. This is all the start and end of the line trace. Start and end of line trace calculations is what I named it. And just so I can actually clearly see where these nodes are going, I'm going to put reroutes on them so that I can space them out better. Clearly see where they're coming from. Now this thing over here, this thing's just going under everything, isn't it? I'm going to move this over here. Just because of the sheer size of this stupid thing, I'm probably going to put in a collapse node just for the heck of it. And I'm going to just shove it in this section over here somehow. All it's doing is getting the break hit result location, so yeah, I'm going to do that. Here's another bundle of references that can just be shoved together in probably one collapse node. Location, tangent, location, tangent. Go for 0, 0, 0, 1, 1, 1. The beam. This is probably the beginning and this is probably the end. Yep, start position, start end position and tangent. Okay, so Yeah, I'm gonna compress all this to get. This is all location values, vectors. Yeah, spline beam vectors. I'll get that. Call it that. Right, and now when I go inside to name these properly, literally just use that as a reference. Done. Really can't mix those up. File to make sure everything's still good. Go back out. Looks clean. Now, slowly I'll be shrinking this more and more so I can move all this stuff closer and closer together so you can see all the information and without having to scroll around everywhere, which is like the end goal we would want. We don't want to have this giant mess to look through. You should be able to understand what's going on without having to move around a lot. Same thing with code. That's why you don't want code generally to be on a single class file more than 250 lines. If it is, then it's time to start making new functions or partial classes, or CPP files, whatever. In my opinion, unless it's like some really crazy advanced stuff or a lot of repetition. I'm trying to see if I can shorten this, but I really can't as far as it goes here. Anything else in this excessive? Probably better to put it there. Okay, good, I can fit it in here. Alright, and that's pretty much the entire rework thing. So now we went from how far back I can go. Okay, so we went from, this is more spaced out version where you get the point from this to what we have now. Where it was all compressed into that tiny little portion. All that done by just moving stuff around and compressing graphs. I didn't create any functions. I didn't have to create any macros. A bunch of reroute nodes and different spacing. Took about 18 minutes though, keep in mind. Give or take a few minutes. This is as much as you would want to do practically though. There's anything more is excessive. Okay, so that's more understandable. Doing that also helps a lot with understanding what happened before. Have that trouble. So this is for the press and release interaction. The only thing that needs is Boolean. Reference y. Hold on. See what they're doing here? This is, while this works, this is kind of a mess. Instead, this is a good time to make a function just for all of it. It looks clean. There's no delays used here. Any of the functions that are being don't require it to be on the level of the event graph, so I probably can show this into a function, so I will. So this was going to here. Let me double check. Let me go back to the original. Yeah. The only thing I deleted? Yeah. So let me just do one of them. If released, it goes to release. Okay. breaking this. I'm gonna do it here. For the sake of my sanity, I'm gonna function. Looks bad. And I'm gonna shove this all into a function in a moment. First I want to break this stuff. Delete this. Get rid of it. That's literally just doing a copy and paste for both input actions. It doesn't like that. Still doesn't like it. Might need a compile done. There we go. Hopefully that would work. Okay, hold on. Let me just go back to the original. Lets me now. Oh, I know what it is. Yeah, I don't think you can do multiple executions. Okay, it needs to be a macro. That's another limitation of functions. You can't do multiple execution thing. Only one. Okay, that's done. That should work exactly as before. Why is this even happening? What I'm wondering. As for this thing, I'll need to figure out why the mesh doesn't move. I'm using camera location and I want it to be updating the mesh's location based on the relative transference to the mesh, yeah. But it wasn't doing that, the mesh didn't move. Inheriting from character. Huh. It's pretty much time to end it. I did some refactoring. I want to figure out this movement, but I'm going to have to stop my urge and just leave it for another time. Probably. If I keep going, it's just going to screw me over later. Hopefully everyone comes to the meeting. I'll definitely be there. Maybe a little bit late, depends on rush hour. We'll figure out at that time. Hold on, I didn't even think I put it on. Just want to make sure everything still works right, even though that was a really basic refactor. It shouldn't break anything, what I just did. Still can. Yeah, it still doesn't work. Possibly because it doesn't use a relative transform. Don't think I can think of. Global transform, maybe. Else. I haven't checked the level blueprint. What I could try doing probably won't work. Try this. Just for the hell of it. What happens? And that's the last thing I'll do tonight. Oh. That definitely did not work. But yeah, definitely don't. I'm gonna commit this now. I did reorganize it and everything seems working. Menu worked when I pressed quit. I didn't check the load stuff, but it doesn't really matter because all I did was mess with the interaction beam. So as long as that works, it's fine. But that's it for today's stream. Hopefully it was useful for both the people who watched it and or the people who watched it in the highlights section for the Spark Dev thing. And I'm ending it now. Bye.